YouTube! Today I'm going to break down why Claude Fable 5, also known as Mythos, isn't actually that important. Hi everyone, and welcome to this episode of Crossover Mind. Now, that's a provocative way to start. A powerful new model just got released to the public, and here I am calling it not important. I bet a lot of you are thinking I'm just being contrarian. But here's the thing. I'm not dismissing the performance itself. Quite the opposite, actually. What I want to talk about today is that the metric that truly matters is starting to shift somewhere else entirely. Let's dig into that. First off, whenever a new model drops, we tend to get all excited. It got smarter, the benchmark scores went up, and that's wonderful in itself. But if you look closely, a lot of the progress over the past few years has been, in a sense, predictable. Make the model bigger, feed it more data, throw a mountain of compute at it, and performance goes up. That's a world that follows the script. And if it's predictable, that means competitors can catch up just by following the same path. We've all seen it, right? A cutting-edge model comes out, and within just a few months, the rivals are right there alongside it. So the arrival of one giant model in the long run isn't all that decisive. What really decides the game is shifting to a competition of efficiency. How smart can you make something at the same size? That's the key point to keep in mind. And this is where Elon Musk's idea comes in. The one he's been championing. Intelligence density per gigabyte. Picture a car, and this becomes really easy to understand. There's a car that just has a big engine and lots of horsepower versus one that competes on how far it can travel on a single liter of gasoline. The latter is the real measure of engineering skill, isn't it? AI is the same. It's not about a model that's just big. It's about how much dense intelligence you can pack into a limited amount of memory. That fuel efficiency is, you might say, going to be the real battleground going forward. What's interesting about Musk is how harshly he judges the current state of things. According to him, the intelligence density we're experiencing in AI right now is far, far below the level we could actually achieve. How far below, do you think? He estimates that just through algorithmic improvements, using the very same computers, we could boost intelligence density by 2 orders of magnitude. That's roughly 100-fold, 100 times. And that's without buying a single expensive new chip. What this means is that we've only pressed the gas pedal of this AI car down just a tiny bit so far. And there's another familiar yardstick he sharply takes issue with. Parameter count. For ages, the industry has talked about how impressive a model is based on whether it has tens of billions or trillions of parameters. But Musk points out that this misses the essence. Because the physical constraint when you actually run an AI isn't the number of parameters. It's the size of the memory and the memory bandwidth, the width of the pipe that data flows through. This is a part that might be a little hard to grasp if you're not deep into the tech. So let me walk through it carefully. Each individual parameter is, in essence, a number. And whether you represent that number with 4 bits, 8 bits, or 16 bits completely changes how much space it takes up. So even if we say 100 billion parameters, the actual amount of data can be a totally different thing. That's exactly why he argues we should discuss efficiency by the real data volume, the file size, rather than the parameter count. Maybe an analogy with tidying up your clothes makes it clearer. It's not about how many you own, but how skillfully you can fold them and fit them into the same drawer. The folding technique is where the real skill shows. So how do you sharpen that folding technique? The key is a technique called low-bit quantization. You boldly cut down the precision of the data. In the common approach today, you train at high precision, like 16 bits, and only compress down to 4 bits when you actually run inference. It's a 2-stage setup. This is an area where the whole industry has made big strides lately. But Musk is looking one step further. He predicts that eventually the training itself will be done at 4 bits or even lower. And if that happens, he believes it'll lead to a huge leap in performance. In fact, chip chip makers are seriously eyeing this 4-bit era too. The latest chips have adopted a new 4-bit floating point format, trying to deliver 16-bit level accuracy at the speed and energy efficiency of 4-bit. In other words, the cleverness of algorithms and the evolution of hardware are starting to join hands perfectly. When both wheels mesh together rather than just one, that's where real acceleration is born. Now, a lot of you are probably worried. Can it really stay smart if you cut down the number of bits? That's a very natural question. How can you maintain high intelligence with less information? Here, Musk gives a rather elegant example. The power of context. Say you want to identify the name of a certain street. If you have no premise at all, you'd have to search among countless streets all over the world, which requires an enormous amount of information. But if you already know that I'm currently in Austin, Texas, the candidates narrow down dramatically, and you can get by with just a tiny bit of information. Do you see? When you have the foundation of context, you can reach high intelligence, the correct answer, even with a small number of bits. Skillfully using the advantage of information is the very heart of efficiency. And Musk also touches on dedicated hardware. A core processor with thousands of tiny cores, specialized only in handling 4-bit or lower processing, he says that might be built into future chips. When this kind of algorithmic efficiency combines with the evolution of dedicated hardware, intelligence density could jump 10 times, even 100 times, all in a short period. That's what he's anticipating. And this efficiency revolution forms the basis of his famous bold predictions. Musk describes AI's capabilities as accelerating like a supersonic tsunami. Specifically, he says artificial general intelligence, so-called AGI, might be achieved around 2025 or 2026, and by 2030, AI could reach a level surpassing the combined intelligence of all humanity. Quite a grand story, isn't it? Of course, when it comes to these timeline predictions, there are voices from cautious experts saying they're too optimistic. I myself think you'd be wise to be careful about taking those years at face value. And the term intelligence density itself actually has some homework left to do. There's the question of what intelligence even is in the first place. If you can't properly define the intelligence in the numerator, then the division called density gets a little fuzzy too, doesn't it? So the people who criticize this metric point out that talking about efficiency alone, while the definition of the content stays undefined, is circular reasoning. And honestly, that's a perfectly fair point in its own right. Even so, there's a reason I want to hold on to this way of thinking. And it's because, interestingly enough, the human brain is the ultimate energy-efficient intelligence. Our brains run on only about 20 watts. Less than a single light bulb's worth of energy. That's an efficiency you simply can't compare to a giant data center burning through megawatts. The brain, too, could be called a kind of biological computer. With a limited number of neurons and limited energy, it produces this much rich intelligence. This is the very model for intelligence density. So, from a competition to build the biggest model, to a competition to build the most efficient model, from horsepower to fuel efficiency. This shift in perspective is what's going to become the real story of AI going forward, don't you think? When you look at it that way, behind the headline news that a giant new model has arrived, what we should really pay attention to is that humble but important number. How small and how energy efficient does this model run? So the next time you come across an AI story, please try looking not just at the smartness, but at the fuel efficiency too. I promise the landscape of the news will start to look a little different. That's where the protagonist of the future is hiding. Thank you so much for joining me on Crossover Mind once again today. On Crossover Mind, we bring you the latest news on technology, business, and society, and dig deep into the important themes that lie beyond it. And please don't forget to subscribe. Until next time, take care. See you